This is a plane table, and this is just like a drawing board. We mount first of all plane table sheet on this. So drawing sheet, when we are mounting, we have to ensure that this sheet is free from wrinkle. Okay. Then we have to ensure that the plane table top is horizontal. So we have to do is by eye judgment only. And once we are sure that this is horizontal, we can make it perfectly horizontal when we keep LED. I'll show you LED. So horizontal we see leveling, and then at the same time we center it over a given point. Like I'll show you, this is the benchmark, or this is the point where we want to keep our plane table. So over this point we are keeping with the help of this plumbing fork. This is the plumbing fork, and we have down below here is the plumb bob, and this plumb bob is indicating the point. So that means if I want to transfer that point, this point is here. So that point, ground point, I can transfer it here. So this is my point on the plane table. Now I can remove it because I know where I have kept the plane table. So there is no need now for this plumbing fork. So this plumbing fork is a very simple equipment. It is in the shape of the fork, and there is a plumb bob suspended with it. So it will show you where you have kept the plane table, or you want to transfer ground point on the plane table, then it is very, very helpful. Can you see this metallic plate here?
Yes, sir. Yes, sir.
So this metallic plate we are keeping, and there are holes in these metallic plates. So these holes are at every 1 centimeter.
Yes.
So what we do is we draw grid first of all on our drawing sheet. So when we draw the grid on our drawing sheet, we have to mark on the map on the sheet these points. So I am marking here every 2 centimeter, every alternate. So you can mark every alternate points all along the 4 edges with the help of this graticule. This frame is called graticule. So with the help of graticule, we are marking the points all along the 4 edges at every 1 centimeter or 2 centimeter interval. Here in our case, we are marking at 2 centimeter interval. And once these points are marked, then what we do is we join these points. So we will join these points something like we use the ruler, and we will draw vertical line and horizontal line. So when you draw these vertical line and horizontal line, it will make a grid. So this sheet becomes like a graph sheet. So we have grid on mark on it, and one of the grids somewhere here when I am working, I can mark that as my origin, and I can plot my control point coordinates.
Yes.
So once I know x-axis, y-axis, I can plot all my control points plane table. So very first thing is that before plotting the details, you have to mark control points with the help of the grid sheet. Okay. Your scale of plotting will be 1:1000. 1000. That's our scale of plotting, okay, for this campus area. Now, once this is done, the control points are plotted. Then I'll show you the next equipment which we are using is very useful equipment, LED. So this equipment has a base, and this base is graduated. Can you see the graduations?
Yes, yes, sir.
Yes. So this is graduated because it will act as a scale. So I don't have to carry another scale. I'll use this scale for drawing the lines. Then there is a magnetic needle. So I show you the needle. So this is the release button for the needle. Right now it is clamped. So this is magnetic needle. Can you see the needle moving now? So this needle keeps on moving.
Yes, sir.
So now needle is indicating that this direction is my north direction. So what I do is that if from A point, if I draw this direction, I get the north direction. I know where the magnetic north is. So this is the magnetic north direction. So I know now this is my north direction. I can orient my plane table every time with respect to this direction, because this is the north direction. Okay. Now another thing which you can see on this is bubble tube. So there is a bubble tube, circular bubble tube, and this bubble, if it is in the center, it means your plane table top is horizontal. So this should be in the center. If it is not in the center, then you have to move 3 legs in the appropriate direction so that it becomes in the middle, center. Then there are 2 vanes. These are the 2 vanes. These are collapsible. These are the collapsible vanes. So these should be perpendicular to the base. This particular vane has small holes. I hope you can see these small holes. So there are 3 holes, and this is the eye vein. Your eye should be towards these holes. The other vein is hollow here. Hollow means that there is a fine thread in the center. Okay. So if there is a fine thread in the center of this is object vein. So this should be towards object. This vein should be towards your eye. Okay. So what we do is that now if I want to bisect any object, let us say from A, this is my station. So if I bisect any object, I'll put my eye here somewhere close to the slit and see this thread, middle thread, and the object. So my eye, the thread portion, fine thread portion, and the object, they should be in one line. If they are not in one line, then what is the option with me? The option is that you can, about this axis, you can rotate it like this and bring all the 3 in one line. So about the station on which you are keeping the plane table, about this axis, vertical axis, you can rotate it so that eye, fine thread in the center, and object, they are in one straight line. So that means I have bisected the object properly. So in plane table, now I have explained you the steps, that you are first of all leveling the top. The second step is you are centering it with the help of the plumbing board. And third is you are finding out the direction of the north. And fourth is how to bisect the object. Is this point clear to you?
Yes, sir.
Okay. Now there are 3 holes here, and I tell you the role of those 3 holes. The middle hole is when the object is higher, so that your eye position is here, thread and the object, you can see them in one line. If the object is lower than your position, then you are using the upper one. Otherwise, we are using if the ground is flat, we are using the middle. Okay. Now I will show you the other telescope, which is other alidate, which is called telescopic alidate. So here, this alidate is telescopic alidate. The advantage of this telescopic alidate is that if the object is far off, probably you cannot see with the ordinary alidate. You need a telescopic view so that you can focus the object you can identify the object, you can focus it very clearly. So if the object is far off, then this instrument is very, very useful. So what we do in the same way, we are keeping that and bisecting the instrument with the help of the telescopic tube, which is given here. The advantage of this instrument is one more, that you can get vertical angle. You may note down vertical angles. So these graduations which are given are the vertical angles. So how much angle is made by this line of sight with respect to horizontal, you also know that the object is making so many degrees vertical angle, because this vertical angle you require in your computation part. So this, the top portion is indicating positive angles, the bottom portion is indicating negative angle, angle of depression, angle of elevation. So while measuring the angles, you have to ensure that the bubble tube is always in the center. Right now it is not in the center, but you have to make it in the center. So this has multiple advantages when long sights are taken, and we don't carry theodolite for vertical angle. So this can straight away give you vertical angle. So you eliminate the use of another instrument in the field. Okay. Now I will show you the use of a clinometer. I'll show the use of the clinometer. This instrument is known as a clinometer. Very, very useful equipment. And what this instrument is, again, there are two vanes. This is the vane towards object, and this is the vane towards the eye. So it has a hole here. There's a hole here. So you have to see the object from this particular hole. Okay. Now there is a base here, and you can see the bubble tube, and this bubble tube indicates that whether the top is horizontal or not, because this instrument is known as a tangent clinometer. It gives vertical angle of the object which we are bisecting. So to measure correct vertical angle, there is a foot screw attached here. So with the help of the foot screws, you have to ensure that the bubble is in the center. So just see, if I move this screw, the bubble moving. Okay. So you have to bring the bubble in the center with the help of the foot screws. So accurately center it. Once you have done it, then you look through the slit here and the object. So your eye line of sight will cut this graduated scale at some point. So when you are bisecting, it will cut at some point. You have to note down that reading. So if you see carefully this one, what is happening here? Now look at the graduations. So this is directly, what is written here is directly tangent theta value, because in trigonometrical calculation we need tangent theta. So instead of vertical angle theta, I get directly tangent theta. So that means you are now eliminating the use of a calculator in the field. So even if you don't have a calculator, you need tangent theta in your computation. You directly read what is tangent theta of that particular object and calculate trigonometrically. If you know one distance, you can calculate small distance. So that is why this is known as tangent clinometer. It gives tangent theta. Theta is the vertical angle. Okay. This is very useful equipment in hilly areas. In hilly areas where some objects are situated on the mountain top and you are standing below the mountain top. So you can directly take the observations of those places with the help of tangent clinometer. Now, how to do the measurement and plotting part on plane table? This I want to explain you. There are two methods. One is radiation method and another is intersection method, which I will explain you today. There are two more methods. So in all there are 4 methods in plane table. So today I will explain you radiation method and intersection method. Radiation method the name itself is giving you that probably this is my starting point. So the rays which I will draw will radiate from this point. Radiate means all around this point I'll take the observations. And when I take the observation and draw the rays, you will find that all the rays are radiating from this point. That is why this method is called radiation method. So we will select the objects which are close by here, like tree, building, telephone poles, road, sewer line. So all the objects which are close by this point, we will plot those points here by radiation method. But if the objects are further away, very far off, then we will go for an intersection. So radiation method is useful when the objects to be plotted are very close to us and they are situated in flat area, plain area. We can measure tape distance very easily. Radiation method is useful when the objects are far off, they are situated on a different hilltops, undulating ground. It is difficult to measure horizontal distance with a tape. So we go for a radiation method. We go for, intersection method. Radiation method is slow in the sense you are taking more number of observations. Intersection method is faster. Okay. So I will first explain you now radiation method of plotting. Okay. So what we do is, if you see the tree behind, I will like to plot this tree. I like to show the location of the tree on my plane table. So how to do it? Very simple. Elidate. I'll use my elidate for bisecting, and I'll get the direction from the elidate, and I will measure the distance with the tape. So I need only two things. If I know the direction of a line and if I know the distance, I can plot it. So same way I will be doing it. Now you see that the distance will be measured with the help of this tape. So zero end will be kept here. So zero end of the tape will be kept at the point, and we will spread the tape and we will see the last reading. So last reading, there is 4.40. So the reading there is 4.40 meter. The scale of plotting is 1:1000. So our scale of plotting is 1:1000. So this distance will be how much? This distance will be 4.4 centimeter on my plane table. So now what I do is that I will start bisecting that tree. So this is my A point. With respect to my A point, I'll bisect this tree. Okay. So I'm bisecting it. My eye on this side, I can see this fine thread and I can see the tree, middle of the tree. So this is my direction. So I know my direction and I know I have to draw 4.4 centimeter distance. So if I draw 4.4 centimeter distance, this is the position of the tree with respect to point A. So I can make a symbol of the tree. Here. This is the symbol of the tree. So the location of the tree now is known to me. Now in second case, what I want to do is, I want to draw the corner of the building. So it is in other direction. So I'll have to bisect that corner. So just see the distance. They are measuring the distance of the corner of that, and now I get the distance. I like to bisect this particular corner. So we are using many times, we are using flags, survey flag. So I keep a flag at that corner, and now I get the direction. I can see that flag, I can see the fine thread in the middle, and I am now this is the line of sight. So I get the direction. So now I am getting the direction, in which direction that corner is situated, and I am getting the distance. So again, using this graduated side of the alidate, I have to draw that line and cut at 1:1000 scale. I have to draw the corner. So this is the corner of the building. Maybe the building later on will go like this, but I don't know. I'll have to take some more observation. So right now I got just one corner of the building. So similarly, now I can take another corner, third corner and fourth corner, and then ultimately maybe my building will come something like this at the end. I don't know. When I take the observation and join, then I'll get the correct shape of the building. So this is the way plotting is done for various objects. Now I'll take another object, which is the corner of the fence. So again we take the distance and convert this distance at 1:1000 scale plotting, and now I'll bisect that area with the help of, we'll keep a flag and now bisect this area. So I have now bisected the flag passing through point A. Again you have to see that everything should be passed from point A, and measure the distance and cut down that distance. So I get the corner of the fence portion. So I get these 3 points. So this way I continue my work, and when I continue my work from this particular point, you will find that there is one electric pole here. So I'll make a symbol of the pole. I'll find one tree here, so I'll make symbol of the tree. So you will find that all these points now are radiating. So from this point all these rays are radiating in all directions. That's why this is called radiation method, and we keep on plotting the object. So this is the way of doing the mapping. But one thing is very important here to know is that when we are doing plotting, we have to do contouring also. Contouring means elevation should be known to us for these points. So how do we know elevation of these points? Very simple way would be that we keep a staff. We keep the staff at that point. So let us keep the staff at that point, and we have close by the instrument called level. So we are now, what we are doing is we have to keep this instrument very close to plane table positions, and we have to keep this instrument very close to plane table positions, and we try to now take the observation of the star. So using the level, now we are taking the observations. We note down the reading, and once we note down the reading, we know the elevation of this point, we can find out elevation of that point. So that is the procedure, that at all the points we have to keep the staff. So now, for example, we have to keep the staff now at another point, building point. So I know elevations of all the points. So what we do is that, suppose elevation of the fence point was 213.34. Elevation of this particular building comes out to be 213.25. So we are writing the elevations value on plane table itself. So all the elevation values are also transferred at the same time. So whenever we are taking the observations, we take the observation for leveling also, so that later on we can draw contours. So this is done for radiation. Okay.